There you go.
Right.
Mr. Potts, like,
Careful, it's being recorded.
yeah, whatever we do after graduation doesn't affect things, like after.
Right, probability distribution. Okay, so page 520. What we're talking, a little bit of notation to start with. So the notation that I want to introduce you to is this. Well, you already recognise that, don't you? What does that mean?
Probability.
So the probability of, and we would have event in there, right? But we're going to change this notation a little bit because we need to use it for our probability distributions. So what we say now is we have the probability that the event is a certain outcome. So we've got a capital X and a little x, right? So that just means the probability that this is going to equal this, right? So the probability of rolling a dice is 6, I would say in that way. Okay. So again, remind you of certain things. The probability of something equaling something, okay, is always between what values? 0 and 1. There you go. So it's always between 0 and 1. Basic stuff. And then I could say this notation. What would you say? You should recognise that shape at the beginning. What does it mean? Sum of. So the sum of equals 1. Simple as that. Okay. So we've just got our. So the sum of all the probabilities for a particular event will equal 1. Right? So it's nothing different, nothing new than you've been doing before. Okay. Now what we're looking at is being able to calculate a particular probability distribution. So I'm going to go through. When we talk probability distribution, we're actually looking at just calculating all the probabilities of every outcome. Okay. So if we have a look at example, let's go for example 2 on page 521. So we are told that a random variable. Now there's something to read there in your book about randomness. Okay, but it's not worth us making a big deal about it, but it's about random variables. Because obviously, if something's not random, it affects its probability. So we're talking random variables. So we're saying that the random variable x, okay, has the probability distribution. So x can be 1, 2, 3, 4, or 5. Okay? And the probability that x will equal x, they give us the probabilities 7c, 5c, 4c, 3c, and c. So, which is the most likely outcome? Well, what's the most likely outcome, though? 1. Yeah. So it's not 7c, that is the probability, but the most likely outcome is the 1. Exactly, that's the probability statement. So, for instance, it says, find the value of c. So, this is basically the fundamentals of probability that you're using, that most probability questions are based upon. So how do I find this value c? Say that again, sorry.
Isn't it all supposed to add to?
Yeah, so we would write 7c plus 5c plus 4c plus 3c plus c should equal 1. And if I do add all that up, what do I get? 7, 12, 16,
20.
so 20c equals 1. Therefore, c will equal
1 over 20.
1 over 20. And we'll leave it like that. The next part of the question says find, and again this is where it's just, the maths itself is not difficult, it's no different to what you've been doing before, but it's just you understand the notation. So when it says find this, alright, you just have to understand what that means. Okay? So what is the probability that x will be greater than or equal to 4?
3c plus c.
So we've got, it's the probability of x equaling 4 and the probability of x equaling 5. So this is obviously showing all my working. You got the right answer, didn't you? Probability that x equals 4 is 3 times 1 over 20. And the probability of x equaling 5 is 1 over 20. Okay. Actually, this word "and", is that the correct word I should use in this concept? It should be "or", because we're saying it's not x is 4 and 5. We're saying it can be 4 or it can be 5. So now we've got the correct word. That means we know what to do with the middle, which is add them together. So we've got 3 over 20 add 1 over 20 gives us the answer 4 over 20, which simplifies to 1 over 5. Okay? So, nothing different. Nothing different there at all. It's just notation at this stage. So, if I can get you now, just have a bit of practice working out the probability distribution. Now, the thing is, this here, okay, this bit is the probability distribution. Alright? So you are actually shown the entire distribution of probabilities. So when we call it probability distribution. So we obviously will get to a point where this becomes a graph. Right? But probability distribution is just a fancy way of saying all the probabilities put in a table. Alright? And we have methods for working out probabilities for different sets of events. What would that be? Are you with us now? Yeah. Fully concentrated? Yeah. What methods have we got for working out probabilities? Tree diagram, Venn diagram, sample space diagram. Okay, so we've got all these methods. We then just use those methods to enable us to find our probability distribution. Okay, so if I get you to have a look at exercise 15A, right, on page 522, we'll do a selection of those questions. If you feel you need to start with questions 1 through 5, go for it. Otherwise, start with the exam style questions 6, 7, 8, 9, 10. Because at this stage, we probably need to be getting used to those. Okay. Any questions before we go on? No?